Number 1, solve the equations below for x. So for each of these exponential equations, notice that the variable is trapped up in the exponent, and we can't use common bases in this first one, so we have to log both sides. You can use the base 10 log, or you can use the natural log, but we log both sides. Because logarithms have this property where the exponent becomes a coefficient. Remember that property of logs, where the exponent becomes the coefficient. Maybe you saw that log base 10 of 10 is 1, but maybe you divided it over, which is what we normally do. But we're really just dividing by 1. So we get x equals log 30 over log 10. So in your calculator, you're going to type that in. Log 30, close the parenthesis, divided by log 10. And we get 1.477. Let's go to 3 decimal places, because it doesn't say. So log 30 over log 10 is 1.477. So that's the value of x that makes that equation true, that solves that equation for us. The next one, the exponential is not by itself, so we're going to add 4 over. And we get 2 to the 3x equals 12. I'm going to log both sides. 2 to the 3x equals log 12. When that variable is in the exponent, it can be brought down front. 3x log 2 equals log 12. And divide by 3 log 2. Log 2 is a number. Divided by 3 log 2. So we get x equals this thing. Well, what is that thing? So if I go to my calculator, if you have a TI-84, use alpha y equals enter to get a fraction. Please use that every time you see a fraction. It's going to make your life so much easier. If not, you need to use parentheses. You need to say log 12 divided by everything that's in the denominator. So I opened a parenthesis, 3 log 2. (1.195) x equals 1.195. That's the value of x that makes that equation true. And the last one, 1 over 16 equals 2 to the 3x minus 1. Well, maybe you didn't realize that you could do common bases here and make that 2 to the negative 4, and you solved it with logs. I'm going to solve it with logs just in case you didn't recognize that common base, that this is actually a common base. It can be solved with common bases. So log both sides, because the exponential expressions is all by itself. Log of 1/16 equals, well, the 3x minus 1 comes down front, log 2. Divide by log 2. So we have log of 1/16 over log 2 equals 3x minus 1. So let's figure out what this number is, add 1 to it, and then divide by 3. Because how do I get x by itself? I add 1, divide by 3. So let's do log of 1/16 divided by log 2. Could have used the natural log here too. If I use the natural log for both, that would be fine. Negative 4 plus 1 divided by 3. Do it in 2 different steps, not like I just did. Add the 1. Divide by 3. So we get x negative 4 equals 3x minus 1. Negative 3 equals 3x. So x equals negative 1. So all of these equations could have been solved with the natural log, but we used the common log, the base 10 log, so that worked too. The big idea is when the variable's trapped in the exponent, we need to use logarithms to bring that down as a coefficient so we can actually solve for it. This first one I'm going to divide by 300. 2 to the t over 5 equals 600 divided by 300, it's 2. So this isn't even, this is also a common base equation because they're both base 2. So you can just set that numerator equal to 1. Or let's go through and solve it with logarithms. multiply by 5, divide by log 2 to get t by itself. And log 2 divided by log 2 is 1, so we get t equals 5. This next one has an e in it, and remember, e is the base of the natural logarithm. The natural log of x is log base e. So whenever we see e in our exponential equations, we want to use the natural log to solve it because it's a lot nicer. But first, that 40's got to go. 5/4 is 1.25. Natural log both sides. I'm going to natural log both sides. And by doing that, I can bring down that exponent. So 0.027t ln equals the ln of 1.25. But the natural log of v is 1. You can even check that in your calculator. Type in ln and you'll get 1. 1 times anything is itself. Divide. And this is what I'm going to type into my calculator. That's the answer expressed as a logarithm. And now I want to round it to the nearest thousandth. Natural log of 1.25 divided by 0.027. 8.26, round that up, 0.265, 8.265. Nearest thousandth means 3 places. This next one awfully looks like a half-life equation. Hopefully you notice that because that base is a 1/2. So, first thing to do is divide by 800. 1/2 to the 0.347t equals, see if that can be simplified nicely. 120 divided by 80 is 3/2 or 1.5. Gonna log both sides. To get t by itself, I need to divide by 0.347 log a half. So if you have a TI-84, use the fraction template. Use the fraction template here and type in log of 1.5 divided by 0.347, 0.347 log of a half. You get negative 1.686. So t equals negative 1.686 because I round up there. As a logarithm, that's the answer. That's the answer written as a logarithm. That's the answer when I solve for t and approximate it using my calculator. The last one. The first thing I need to do is subtract over that 68. We get 102 equals 136 e to the 6k. I'm going to divide by 136 before I log both sides. That does not look like a nice number, so I'm going to leave it. Because I have an e, I'm going to natural log both sides. When I natural log both sides, that exponent comes down front, and we all know the ln of e is 1. So all I have to do is end up dividing by 6. So that's the answer as a logarithm. What's it as a decimal? Well, let's do the natural log of 102 divided by 136, close that parenthesis, divided by 6. And guess what? If you had the fraction template, you could use that here. So k is approximately negative 0.04, round that up to 8. Negative 0.048. So when we solve exponential equations, when the variable is trapped in the exponent, we log both sides. That's the strategy for solving these exponential equations.